Well, after actually thinking about it for a minute or two, was it obvious to me that this is more of a silly rant than anything constructive. But maybe one day, if I remove some profanity from this page, I will make something constructive out of it. Quite a lot of the evenings of the last few years I have spent on educating me more about my profession, the information technology. So I went to this failed MICROFT Academy, some local community college, and here is what I have learned there. Basically the thing is quality of the factory-like education, so it's about quantity and not about quality, really sucks. Now here are something, around 5 main aspects of it, that you can learn. But they are all bastardized. The stuff that is being taught is all such MICROFT biased bullshit, and nothing of what you really should be learning. In the end I decided that it makes more sense to finish Linux Foundation System Administration online course than spend even more of my time where they don't even know what they are speaking about. For example, I have already taken Introduction to Linux, and it was actually fun. These are the 5 main aspects of it that I think are important, and are at least correct to mention in this context. 1. Computer architecture and history of its development/evolution. 3. 2-bit PC only versus 16-bit era. 2. Operating systems scheduling versus FHS. 3. Databases relations as arrows between tables versus relations, as in data type relations, and not some other nonsense. 4. Network MOSI versus TCP/IP. 5. Programming/scripting OOP phonetical madness versus the bash/shell and open source scripting revolution. Now let's look at each of them separately. 1. Computer architecture and history of its development/evolution. 3. 2-bit PC only versus 16-bit era. The first ever step in starting to learn something about computers often starts with a computer architecture. But supposedly it looks like there exists some alternative histories for different people. I have seen it already a few times, when people start with punch cards, and then directly switch to the ISA bus, and SIBUS, and different Intel processors generations, together with AMD, like the IBM PC, was the first computer ever created. Like the legendary 8-bit to 16-bit era, switch never happened. Like Commodore Amiga wasn't the one, and only of its kind. Like it haven't used the legendary 68K RISC microprocessor from the PDP mainframes. Like Linux has never been ported to 68K, and it haven't set it off as the most portable OS ever. History of computers / the rise of the microcomputer. How computers work. Code.org. Steve and Bill Balba for C64. 2. Operating systems scheduling versus FHS. You see, some other lesson, we started studying operating systems. My favorite subject. And there we go, we started to draw some round robin, like scheduling schemas on a sheet of paper, with a pencil. Really? Why the freaking hell, you would start telling me about scheduling algorithms, and don't even mention the FHS, the first ever thing you should be learning about operating systems. Read Andrew Tannenbaum's Modern Operating Systems, that even Linus Torvalds endorses. Here is what he writes. The amount of space devoted to some of these topics is different than in some other books, however reflecting my belief that students should learn about concepts that are of practical value in real systems, rather than those that are just of theoretical interest. For example, CPU scheduling is worth a section, not a whole chapter. Many complicated scheduling algorithms have been proposed and analyzed in the literature, but most real systems just use some kind of simple priority or round-robin scheme. Happily, there are some local Linux gurus who write introductory books on Linux, and it's even available in HTML form online. Linux sysadmin evolution. And don't even get me started on how one security specialist started telling us about how we should first back up our data center in case we had decided to defragment it. I'm sorry, but this is some fat bullshit. This is so wrong on so many levels. Maybe you will defragment the ZFS too? How about copy, unwrite file system snapshots ZFS On a little bit more serious note, I've heard this should be a good book, on operating systems. 3 easy pieces. 3 databases relations as arrows, between tables versus relations, as in data type relations, and not some other nonsense. Here we go again. When you start reading right books, instead of listening to fools, you discover that a relation, in the database world, has nothing to do with arrows, between tables and everything, to do with types of data. Just go and take a look at the JC Dates database, in-depth book, page 46, where he explains what a relation is. I'll leave it as an exercise to interpret the supplier's relation in terms of the foregoing definition. However, I will at least explain why we call such things relations. Basically, each tuple in a relation represents an n-ary relationship in the ordinary natural language sense, among a set of n values, one value for each tuple attribute, and the full set of tuples in a given relation represents the full set of such relationships that happen to exist at some given time, and mathematically speaking, that's a relation. Thus, the explanation, often heard to the effect that the relational model is so called because it lets us relate one table to another, though accurate in a kind of secondary sense, really misses the basic point. The relational model is so called because it deals with certain abstractions that we can think of as tables, but are known formally as relations in mathematics. Discovering JavaScript Object Notation with Douglas Crockford. Page views URL and counting visits, accurate visits, unique visitors URL, and counting visits, accurate visits for specialization. For networking OSI versus TCP/IP, OSI versus TCP/IP comparison with TCP/IP model. The design of protocols in the TCP/IP model of the Internet does not concern itself with strict hierarchical encapsulation and layering. Left bracket 26 right bracket RFC 3439 contains a section entitled Layering, considered harmful. Left bracket 27 right bracket TCP/IP does recognize 4 broad layers of functionality, which are derived from the operating scope of their contained protocols. The scope of the software application, the end-to-end transport connection, the internetworking range, and the scope of the direct links to other nodes on the local network. Left bracket 28 right bracket. Despite using a different concept for layering than the OSI model, these layers are often compared with the OSI layering scheme in the following way. The Internet application layer includes the OSI application layer, presentation layer, and most of the session layer. Its end-to-end transport layer includes the graceful close function of the OSI session layer, as well as the OSI transport layer. The Internet layer is a subset of the OSI network layer. The link layer includes the OSI data link layer, and sometimes the physical layers, as well as some protocols of the OSI's network layer. These comparisons are based on the original 7-layer protocol model, as defined in ISO 7498, rather than refinements in such things as the internal organization of the network layer document. Left bracket citation needed right bracket. The presumably strict layering of the OSI model, as it is usually described, does not present contradictions in TCP/IP, as it is permissible that protocol usage does not follow the hierarchy implied in a layered model. Such examples exist in some routing protocols, e.g. OSPF, or in the description of tunneling protocols, which provide a link layer for an application, although the tunnel host protocol might well be a transport, or even an application layer protocol in its own right. Some Red Hat girl has been saying that the top-down networking book's supposed to be good, but I seem to think that this one should be it. High Performance Browser Networking. 5 Programming/Scripting OOP Fanatical Madness versus the Bash/Shell and Open Source Scripting Revolution. OOP is to write in a program, what going through airport security is to fly OOP criticism. The OOP paradigm has been criticized for a number of reasons, including not meeting its stated goals of reusability and modularity left bracket 37 right bracket, left bracket 38 right bracket, and for overemphasizing one aspect of software design and modeling data/objects at the expense of other important aspects. Computation/algorithms. Left bracket 39 right bracket left bracket 40 right bracket. Luca Cardilli has claimed that OOP code is intrinsically less efficient than procedural code, that OOP can take longer to compile, and that OOP languages have extremely poor modularity properties with respect to class extension and modification, and tend to be extremely complex. Left bracket 37 right bracket. The latter point is reiterated by Joe Armstrong, the principal inventor of Erlang, who is quoted as saying, left bracket 38 right bracket. The problem with object-oriented languages is they've got all this implicit environment that they carry around with them. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. A study by Patek et al. Has shown no significant difference in productivity between OOP and procedural approaches. Left bracket 41 right bracket. Christopher J. Date stated that critical comparison of OOP to other technologies, relational in particular, is difficult because of lack of an agreed upon and rigorous definition of OOP. Left bracket 42 right bracket. However, Date and Darwin have proposed a theoretical foundation on OOP that uses OOP as a kind of customizable type system to support RDBMS. Left bracket 43 right bracket. In an article, Lawrence Grobner claimed that compared to other languages, Lisp dialects, functional languages, etc., OOP languages have no unique strengths and inflict a heavy burden of unneeded complexity. Left bracket 44 right bracket. Alexander Stepanov compares object orientation unfavorably to generic programming. Left bracket 39 right bracket. I find OOP technically unsound. It attempts to decompose the world in terms of interfaces that vary on a single type. To deal with real problems, you need multi-sorted algebras, families of interfaces that span multiple types. I find OOP philosophically unsound. It claims that everything is an object. Even if it is true, it is not very interesting. Saying that everything is an object is saying nothing at all. Paul Graham has suggested that OOP's popularity within large companies is due to large and frequently changing groups of mediocre programmers. According to Graham, the discipline imposed by OOP prevents any one programmer from doing too much damage. Left bracket 45 right bracket. Steve Yeg noted that as opposed to functional programming. Left bracket 46 right bracket. Object-oriented programming puts the nouns first and foremost. Why would you go to such lengths to put one part of speech on a pedestal? Why should one kind of concept take precedence over another? It's not as if OOP has suddenly made verbs less important than the way we actually think. It's a strangely skewed perspective. Rich Hickey, creator of Clojure, described object systems as overly simplistic models of the real world. He emphasized the inability of OOP to model time properly, which is getting increasingly problematic as software systems become more concurrent. Left bracket 40 right bracket. Eric S. Raymond, a Unix programmer and open source software advocate, has been critical of claims that present object-oriented programming is the one true solution, and has written that object-oriented programming languages tend to encourage thickly layered programs that destroy transparency. Left bracket 47 right bracket. Raymond compares this unfavorably to the approach taken with Unix and the C programming language. Functional thinking. Paradigm over syntax. Computer languages history, the prominent books at the time, and other circus. 1. The other day I was chatting with a guy of around 20 years old, who is studying computer security, and I wanted to say that maybe using some programming language from the 80s is not the best idea to build some modern application. And I wanted to make my point by comparing on which hardware that 80s technology was used/invented. and compare it to its hardware. This way the following timeline came up. Here you can see, for example, that Java was invented before even the first widely available 32-bit consumer computer came out. I'm not even talking already about C++, which was an entire decade before that. And yes, only the Mosine hackers scream Amiga once in a while. Too, then I wanted to add some books in between. Because you know I bought maybe like 100 programming books in the last several years. Of course I only have read half of them. But anyway, here you can see the Unix Hater's Handbook, which can tell you everything you need to know about antiquated C++. The Bite of Python is the best scripting beginner book. And if you want to move on further, after that the Book of Ruby is interesting too. JavaScript, the world's most misunderstood programming language. Douglas Crockford, www.crockford.com. JavaScript Akamoka, AkaLibScript, AkaJScript, AkaECMAScript is one of the world's most popular programming languages. Virtually every personal computer in the world has at least one JavaScript interpreter installed on it and in active use. JavaScript's popularity is due entirely to its role as the scripting language of the WWW. Despite its popularity, few know that JavaScript is a very nice dynamic, object-oriented general-purpose programming language. How can this be a secret? Why is this language so misunderstood? The name, the Java prefix, suggests that JavaScript is somehow related to Java, that it is a subset or less capable version of Java. It seems that the name was intentionally selected to create confusion, and from confusion comes misunderstanding. JavaScript is not interpreted Java. Java is interpreted Java. JavaScript is a different language. JavaScript has a syntactic similarity to Java, much as Java has to C, but it is no more a subset of Java than Java is a subset of C. It is better than Java in the applications that JavaScript was originally intended for. JavaScript was not developed at Sun Microsystems, the home of Java. JavaScript was developed at Netscape. It was originally called LibScript, but that name wasn't confusing enough. The script suffix suggests that it is not a real programming language, that a scripting language is less than a programming language. But it is really a matter of specialization. Compared to C, JavaScript trades performance for expressive power and dynamism. Lisp in C's clothing. JavaScript's C-like syntax, including curly braces and the clunky for statement, makes it appear to be an ordinary procedural language. This is misleading because JavaScript has more in common with functional languages, like Lisp or Scheme, than with C or Java. It has arrays instead of lists, and objects instead of property lists. Functions are first class. It has closures. You get lambdas without having to balance all those errands. Typecasting. JavaScript was designed to run in Netscape Navigator. Its success there led to it becoming standard equipment in virtually all web browsers. This has resulted in typecasting. JavaScript is the George Reeves of programming languages. JavaScript is well suited to a large class of non-web related applications moving target. The first versions of JavaScript were quite weak. They lacked exception handling, inner functions, and inheritance. In its present form, it is now a complete, object-oriented programming language. But many opinions of the language are based on its immature forms. The ECMA committee, that has stewardship over the language, is developing extensions, which while well-intentioned, will aggravate one of the language's biggest problems. There are already too many versions. This creates confusion. Design errors. No programming language is perfect. JavaScript has its share of design errors, such as the overloading of class, to mean both addition and concatenation with type coercion, and the error prone with statement, should be avoided. The reserved word policies are much too strict. Semicolon insertion was a huge mistake, as was the notation for literal regular expressions. These mistakes have led to programming errors, and call the design of the language as a whole into question. Fortunately, many of these problems can be mitigated with a good LINQ program. The design of the language and the whole is quite sound. Surprisingly, the ECMAScript committee does not appear to be interested in correcting these problems. Perhaps they are more interested in making new ones. Lousy implementations. Some of the earlier implementations of JavaScript were quite buggy. This reflected badly on the language. Compounding that, those implementations were embedded in horribly buggy web browsers. Bad books. Nearly all of the books about JavaScript are quite awful. They contain errors, poor examples, and promote bad practices. Important features of the language are often explained poorly or left out entirely. I have reviewed dozens of JavaScript books, and I can only recommend one. JavaScript, The Definitive Guide 5th edition, by David Flanagan. Attention authors, if you have written a good one, please send me a review copy. Substandard Standard. The official specification for the language is published by ECMA. The specification is of extremely poor quality. It is difficult to read and very difficult to understand. This has been a contributor to the bad book problem because authors have been unable to use the standard document to improve their own understanding of the language. ECMA and the TC39 committee should be deeply embarrassed. Amateurs. Most of the people writing in JavaScript are not programmers. They lack the training and discipline to write good programs. JavaScript has so much expressive power that they are able to do useful things in it anyway. This has given JavaScript a reputation of being strictly for the amateurs, that it is not suitable for professional programming. This is simply not the case. Object-oriented. Is JavaScript object-oriented? It has objects which can contain data, and methods that act upon that data. Objects can contain other objects. It does not have classes, but it does have constructors, which do what classes do, including acting as containers for class variables and methods. It does not have class-oriented inheritance, but it does have prototype-oriented inheritance. The two main ways of building of object systems are by inheritance as a, and by aggregation as a. JavaScript does both, but its dynamic nature allows it to excel at aggregation. Some argue that JavaScript is not truly object-oriented because it does not provide information hidden. That is, objects cannot have private variables and private methods. All members are public. But it turns out that JavaScript objects can have private variables and private methods. Click here now to find out how. Of course, few understand this, because JavaScript is the world's most misunderstood programming language. Some argue that JavaScript is not truly object-oriented, because it does not provide inheritance. But it turns out that JavaScript supports not only classical inheritance, but other code reuse patterns as well. Copyright 2001 Douglas Crockford. All rights reserved worldwide. Revenge of the Nerds. Want to start a startup? Get funded by Y Combinator. May 2002. We were after the C++ programmers. We managed to drag a lot of them about halfway to Lisp. Guy Steele, co-author of the Java spec. What made Lisp different? When it was first developed, Lisp embodied 9 new ideas. Some of these we now take for granted, others are only seen in more advanced languages, and 2 are still unique to Lisp. The 9 ideas are, in order of their adoption, by the mainstream. Conditionals. A conditional is an if-then-else construct. We take these for granted now, but Fortran 1 didn't have them. It had only a conditional go-to closely based on the underlying machine instruction. A function type. In Lisp, functions are a data type, just like integers or strings. They have a literal representation, can be stored in variables, can be passed as arguments, and so on. Recursion. Lisp was the first programming language to support it. Dynamic typing. In Lisp, all variables are effectively pointers. Values are what have types, not variables, and assigning or binding variables means copying pointers, not what they point to. Garbage collection. Programs composed of expressions. Lisp programs are trees of expressions, each of which returns a value. This is in contrast to Fortran and most succeeding languages, which distinguish between expressions and statements. It was natural to have this distinction in Fortran 1 because you could not nest statements. And so while you needed expressions for math to work, there was no point in making anything else return a value, because there could not be anything waiting for it. This limitation went away with the arrival of block-structured languages, but by then it was too late. The distinction between expressions and statements was entrenched. It spread from Fortran into Algol, and then to both their descendants. A symbol type. Symbols are effectively pointers to strings stored in a hash table. So you can test equality by comparing a pointer instead of comparing each character. A notation for code using trees of symbols and constants. The whole language, there all the time. There is no real distinction between read time, compile time, and run time. You can compile or run code while reading, read or run code while compiling, and read or compile code at runtime. Running code at read time lets users reprogram Lisp's syntax. Running code at compile time is the basis of macros. Compiling at runtime is the basis of Lisp's use as an extension language in programs like Emacs. And reading at runtime enables programs to communicate using S expressions, an idea recently reinvented as XML. When Lisp first appeared, these ideas were far removed from ordinary programming practice, which was dictated largely by the hardware available in the late 1950s. Over time, the default language, embodied in a succession of popular languages, has gradually evolved toward Lisp. Ideas 1 to 5 are now widespread. Number 6 is starting to appear in the mainstream. Python has a form of 7, though there doesn't seem to be any syntax for it. As for number 8, this may be the most interesting of the lot. Ideas 8 and 9 only became part of Lisp by accident, because Steve Russell implemented something McCarthy had never intended to be implemented. And yet these ideas turn out to be responsible for both Lisp's strange appearance and its most distinctive features. Lisp looks strange not so much because it has a strange syntax, as because it has no syntax. You express programs directly in the parse trees that get built behind the scenes when other languages are parsed, and these trees are made of lists, which are Lisp data structures. Expressing the language in its own data structures turns out to be a very powerful feature. Ideas 8 and 9 together mean that you can write programs that write programs. That may sound like a bizarre idea, but it's an everyday thing in Lisp. The most common way to do it is with something called a macro. The term macro does not mean in Lisp what it means in other languages. A Lisp macro can be anything from an abbreviation to a compiler for a new language. If you want to really understand Lisp, or just expand your programming horizons, I would learn more about macros. Macros in the Lisp sense are still, as far as I know, unique to Lisp. This is partly because in order to have macros you probably have to make your language look as strange as Lisp. It may also be because if you do add that final increment of power, you can no longer claim to have invented a new language, but only a new dialect of Lisp. I mention this mostly as a joke, but it is quite true. If you define a language that has char, cdr, cons quote, con, atomic, and a notation for functions expressed as lists, then you can build all the rest of Lisp out of it. That is in fact the defining quality of Lisp. It was in order to make this so that McCarthy gave Lisp the shape it has. https://sharpforfunandprofit.com/posts/sharp is the best enterprise language / YF is the best enterprise language 20th December 2018. This post is part of the 2018 F Advent Calendar. Check out all the other great posts there. And special thanks to Sergey Tihan for organizing this. YF is the best enterprise language is not meant to be a clickbait title, it is my sincere opinion, and in this post I will attempt to justify it. If you stick around to the end, I hope that you will agree, or at least be a little bit persuaded. Read on. Just to be clear, I am only going to be talking about so-called enterprise development. I am not claiming that F is the best for systems programming, or games development, or hobby projects. WHATS, appropriate for one kind of development objective, may well be inappropriate for another. Enterprise development has its own constraints and demands, which I think F is particularly well suited for. I'll start with an important caveat, which is that I don't think that the success or failure of a project depends on using a particular programming language. Much more critical are things like good communication, clear requirements, caring about the user experience, realistic expectations, and so on. If the programming language really was that important, then there would be no successful companies using PHP, Visual Basic, or JavaScript, and all jobs would require Haskell and Lisp skills. Nevertheless, having said that, I do think that the choice of programming language has an effect on productivity, maintainability, and stability, and THATS, what I am going to talk about in this post. Of course, ITS, easy to prove an assertion, like F is the best enterprise language. All I need to do is choose from one of the numerous longitudinal studies on enterprise software projects. Or failing that, one of the many controlled experiments, which involve large numbers of experienced developers. Hahaha. Of course, there is no such thing. For $1 trillion industry, ITS, shocking that we generally make our decisions using not much more than anecdotes, outdated myths and gut feelings. **********. Yes, I know about neverworkintheory.org and evidencebaseds.com, but I stand by my point. So I don't have any hard evidence, alas, but I will at least try to present a well-reasoned argument. I'll present my premises, and then my conclusion. If you agree with my premises, I hope that you will at least take my conclusion seriously. The characteristics of enterprise development. So what are some of the key characteristics of enterprise development?